first one here, we're going to do study check 12.6. And this is just calculate the grams of KCl and an 8% by mass KCl solution. Now, I am a big pictures person in terms of trying to get people to understand what's going on. So, I'm going to draw a picture of my solution because I think it helps. An 8% by mass solution means that if I put exactly 100 grams of solution in a little beaker, 8 of those grams are KCl. That's what it means to have an 8% solution. The reason I knew to go with grams and grams was because of the mass and the mass piece of that right there. So that's the meaning of an 8% by mass solution. So I need to figure out, I think I need to figure out how much of this I have. I think I left out a word in my example problem here because we haven't got anything to work with. Study check 12.6. We definitely don't have enough information here to do anything. Haha. Calculate the grams of KCl in 225 grams of our solution. So the way I see it, this just makes a conversion factor. Every 100 grams of solution contains 8.00 grams of KCl. And I can be done in a one-step dimensional analysis process. I've got 225 grams of solution. Every 100 grams of solution contains 8.00 grams of KCl. So in that solution, I have 18.0 grams of KCl. And then I ask myself, does it make sense? Well, I'm going to get 8 grams if I only have 100 grams of solution. If I have more than 100 grams of solution, in the end, I must have more than 8 grams of KCl. Bam, problem solved. I have got a preference for this method over the method of using those formulas and trying to solve for the missing variable, because this way I don't have to remember all those formulas. I don't have to get hung up with the whole times 100 thing, which seems to make the algebra get really nasty and messy. I think it's easiest just to draw a picture of 100 of whatever it is I'm working with, figure out what's in it, write a conversion factor, and do the dimensional analysis. It makes every single problem basically the same and avoids me having to remember all those different formulas. Okay, here's a slightly more complicated one because it brings in a medical story. In 2010, the FDA approved a 2% mass volume solution of morphine oral solution to treat severe or chronic pain. How many grams of morphine does a patient receive if we give this person 0.60 milliliters of a 2% mass volume morphine solution? Okay, so the first thing is to think about having some of this solution. Okay, so now we're dealing in medicine. We'll draw it in a bottle because medicine comes in a bottle. That's not really a great bottle, but there we go. There's some morphine solution. Now, when I think about my bottle of morphine solution, I'm going to think about having 100 milliliters of this. It's going to simplify my thought process. I did it in terms of milliliters because it was a mass volume situation. In my bottle of morphine, because I bought the 100 milliliter bottle, I know that I have 2.0 grams of morphine dissolved in here. And now I have a patient okay. My patient is unhappy because my patient is having pain. And I'm going to take some of this, not the whole bottle, because the whole bottle is probably way, way, way too much. I'm going to take some of this and I'm going to give it to the sad patient. So I'm going to take out of here into this person's mouth 0.60 milliliters of this stuff to try to make my patient not be in pain any longer. So we need to figure out how much morphine sad patient is going to get. Well, sad patient just received 0.60 milliliters of solution out of my bottle. My bottle is definitely large enough to provide service to an awful lot of patients. And for every 100 milliliters of solution, I have 2 grams of morphine. .60 times 2 divided by 100. 0.012 grams of morphine. And then I do a quick, does this make sense? I didn't give the patient the whole entire bottle. If the patient took the whole entire bottle, they would receive 2 grams. The patient didn't take the whole entire bottle. In fact, they didn't take much of the bottle at all, so they didn't get much of the morphine at all. Okay, success. One more. A doctor orders us to give 0.075 grams of chlorpromazine, which is used to treat schizophrenia. So our patient needs that much. We have this stock solution that's 2.5% mass volume. Now we have to decide what we need to give to our patient. Okay. Again, pictures are going to be our friend. It's medicine again. I'm going to put it in a bottle. The Dorner Pharmacy purchases everything in 100 milliliter increments. The pharmacy does it that way because it's easier. Volume, so that's milliliters. I might own some medication in 100 gram increments. So this contains 2.5 grams of this stuff. Oh, my label doesn't fit on my bottle. And here's my patient. Who, due to the fact that they're suffering from schizophrenia, is feeling a bit confused in the head. Now, to make patient feel better, the doctor says that the thing we need to do is take out of our bottle 0.075 grams of our medicine and put it into the patient's mouth. And then our patient will be less alarmed because they will feel less confused in the head because they'll have the medicine they need to treat their illness. We just got to figure out how many milliliters of this to give to the patient And obviously not the whole bottle, because that would be 2.5 grams, and that is way, way, way more medication than the doctor says that this poor person needs. So we do not want to over-medicate our patient. So the patient needs 0.075 grams of this stuff. I don't know who names medication. And we are going to get 2.5 grams of this. In every 100 milliliters. I think we're going to administer to our patient 3 milliliters of the solution. And then again, we say to ourselves, does it make sense? Does it seem reasonable to give somebody 3 milliliters of medication? Yeah, it does. I mean, it's way less than the whole bottle, which is good. And since we only own one bottle, it's not like 6 bottles, which is even better. And so our answer here ends up being somewhat reasonable. This is my preferred way of handling the percent solution problems. You don't necessarily need to draw the person on the back end who's receiving it, but if it makes you feel better to draw the little person on the back end, just as a reminder to yourself that this does have some context, by all means, go ahead and draw the little person. But I think the drawing that shows you 100 whatevers of your solution makes it a whole lot easier to think through these percent concentration problems.